Let us understand the details with respect to Pandas. Pandas is not a core Python module and hence we need to install using pip. This is the command which you can use to install Pandas using pip. If you are using Jupyter based environment, you have to have exclamation mark at the beginning and then you can say pip install Pandas as part of one of the cells. The syntax will look like this if you are using Jupyter based environment. We will see the demo in a moment. When it comes to Pandas, it has two types of data structures. One is series, second one is data frame. Series is a one-dimensional array while data frame is a two-dimensional array. Series only contains index for each row and one attribute or column. Data frame contains index for each row and multiple columns. This is the difference between series and data frame. When it comes to data frame, each attribute in the data frame is nothing but a series. We can perform all standard transformations using Pandas APIs on top of series or data frame. The transformations are nothing but projection, filtering, aggregations, sorting, ranking, etc. We also have SQL-based wrappers on top of Pandas where we can write queries. However, we need to install additional libraries and then we have to create a data frame. Then we should be able to register the data frame as an SQL style object. Then we should be able to use those wrappers and write queries on top of it. As it is not a very popular choice with respect to Pandas, I will not be covering that aspect here. That being said, here are the steps to get started with Pandas data structures. We need to ensure that Pandas library is installed using pip. Once it is installed, we have to import Pandas. You can actually say as pd like this to refer all the APIs and classes within Pandas library using this shorthand pd. Otherwise, you have to say pandas dot. To avoid that, I just have this as pd. Now, we need to have a collection or data in a file to create Pandas data structures. Without data, you will not be able to create the data structures. Either you can have data in the form of a collection or in the form of a file. Once you have the data in the form of a collection or file, we can use appropriate APIs on the data to create Pandas data structures, series for single dimension array and data frame for two-dimension array. Typically, we use series for list of regular objects or dict and data frame for list of tuples or list of dicts. Let us use list for series and list of dicts for data frame. This is how we can install Pandas using Jupyter. You just have to say exclamation mark pip install Pandas. If you want to install Pandas using terminal, you just have to say pip install Pandas. Provided you are in the environment where pip is already available for you, it will take care of installing the libraries required for Pandas. Pandas is a big library. It will take care of installing all those additional libraries along with Pandas itself in case Pandas is not already installed for you. In my case, it is already installed. That's why it is saying requirement already satisfied when it comes to all these libraries which are associated with Pandas. Once it is installed, we should be able to import Pandas. I am using import Pandas as pd so that I can refer all the classes and functions in Pandas library as pd instead of Pandas. It is just to type few characters rather than typing the complete Pandas. Now, to create a series, we need to have the data in a file or in a list. So in this case, I am creating a list with float values. You can see that each element in this list is of type float. You can explore the series. Series takes several arguments. One is data, second one is index, third one is dtype, fourth one is name, so on and so forth. The first argument is data. Without specifying the data as the keyword, if you just pass the collection to it, it will interpret the collection as data and it will create a series for you. However, if you want to provide name or dtype for the series, you have to use these additional keyword arguments such as dtype, name, etc. So in this case, this will take care of creating the series with name as sal. You can actually see the results of series by saying sals underscore yes like this. You can see that it have index for each and every record and the corresponding value, and also the name of the attribute is displayed here along with the data type. So the name of the attribute is sal and the data type is float64. Now, as this is nothing but a single dimension list or array, we should be able to perform all standard list operations on top of series. So in this case, if you want to get the first element in series, you can say sals of 0 like this using square brackets. If you want to get first two elements, you can say colon 2 like this. This is how you should be able to access the elements in series. We will explore the APIs that are available on top of series at a later point in time. Just to get started, we have created the series object and we have referred the indexes to get the elements from that series object. Now, before creating the data frame, we need to have list of tuples or list of dicts. In this case, we are using list of tuples. If you look at each element in this list of tuples, it contains two elements. One is ID, second one is sal. Using this list of tuples, we will be creating the data frame. Let's first create this list of tuples. The name is sals_ld. You can explore pd.dataframe. You can see the details here. It takes arguments such as data, index, columns, dtype, copy, etc. To actually create data frame with appropriate names, we'll be using data and columns. When it comes to columns, we have to pass it as a collection or iterable, and this is how we should be able to create the data frame with two columns, id and sal. In this case, both of the columns are passed as list here. Now we should be able to run this. Sals_df is of type data frame. You can run this to actually get the results from the data frame. You can see the index for each and every row and also attributes for each and every column. Attribute names are nothing but id and sal. Now, if you want to access all the values from a given column, you can actually say sals_df like this, and then you can say id. It will take care of getting the elements from one column. You can see the output similar to what we have seen with respect to series. Because each attribute in a data frame is nothing but a series, the output is like this. So this is how you should be able to create a data frame and access elements from the data frame. We will be exploring the APIs that are available on top of data frames to process the data as we get into the subsequent topics in this section.